Hello, my darlings. Today we are going to be looking at classifying matter. So by the end of this video, you should be able to differentiate, tell the difference between elements, compounds, molecules, and mixtures. Let's get started. We're going to start off today's video with a little bit of a joke. So we have two scientists looking at the periodic table and he goes, "Right there, do you see it?" She goes, "Oh my God, I can't believe it." This is the, of course, element of surprise. So let's start off with elements. So elements are a pure, and that is an important word right there, pure chemical substance made from one type of atom, one single type of atom. Some examples would be things like oxygen, carbon, hydrogen. We saw this a little bit with our previous video. If you take elements and combine them, then you are going to create either a molecule or a compound. These are, again, that really important word there, pure chemical substances made from two or more types of atoms that are chemically bonded together. If the atoms are the same, it's a molecule. If the atoms are different, it's a compound. All right, so for example, you can see here, I have two different examples. Oxygen gas, the gas that we breathe, isn't just oxygen, like oxygen on the periodic table. It's actually one oxygen atom bonded together with another oxygen atom. We call this O2. Oxygen gas is a molecule because those are the same atom bonded together. Now, on the other hand, we breathe out carbon dioxide. Carbon dioxide is two oxygens and one carbon. That's why we always abbreviate this as CO2. So, two oxygens, one carbon. Notice that these are different, right? So, because they are different, CO2 is technically a compound. Now, mixing elements can give you all kinds of weird and wacky things. So for example, I can mix sodium, which is a metal, with chlorine, which is a gas, and when those two things bond together, Na, that's sodium, and Cl, that's chlorine, I get table salt, which is super weird. So compounds and molecules can be created, they can end up looking very, very different than the elements that combine to make them. Now, our final thing we're looking at is mixtures. Now, remember from before, I kept on emphasizing that idea of pure. Well, mixtures are not pure. They are not a pure chemical substance. Instead, this is going to be a physical combination of two or more different substances. Okay, so some examples: salt water, air, soil. Salt water, right? I am literally mixing salt and water together. Chocolate milk. I'm mixing milk and chocolate together. Now, an important note here is that mixtures don't make a new substance. It might seem like it's new because we might give it a different name, but it's not actually. So what I mean by that is, for example, salt water, right? We might think like, well, salt water is totally different than water. Okay, but it's still just salt and water, right? If you can separate it back out, so for example, if I stirred salt and water and then I left it there, I might get some salt at the bottom. Or if the water were to evaporate out, I'd get just salt again. If you can reverse it, this is reversible, then you have a mixture. That's a really good hint that you have a mixture. Or if you didn't make a new substance. Now, we have two types of mixtures. The first one is called a solution, or sometimes called a homogeneous mixture. The second one is called a heterogeneous mixture. So homo means the same. And this is where your mixture is spread out thoroughly. So you cannot see the different parts of the mixture. It looks like it's all perfectly blended together. So an example of this might be like salt water, right? Because that salt perfectly dissolves in the water. You no longer could like see how you could separate out one from the other. Now, a solution is always made up of two parts. You have a solute and a solvent that make a solution. So the solute is what gets dissolved. The solvent is what causes the solute to dissolve. So in the case of my salt water, right, the thing getting dissolved, that would be the salt. So the salt would be the solute. The thing that's doing the dissolving would be the water. So the water would be the solvent. The solution is the result. So in this case, the solution would be salt water. Heterogeneous mixtures, hetero means different. And so in this case, you're able to see the different parts of the mixture. It has a higher concentration of one thing compared to another. So usually with this, it's very easy to like sort it out or to like see how it's been mixed together. So like up here, I have some kind of platter of stuff. You can easily sort out one thing from another here. So this is a heterogeneous mixture. Just to give you a couple of other examples, right? A rock like this, where I can sort out those different parts, that would be a heterogeneous mixture. Soda, where that sugar and water, that's essentially what soda is mixed together thoroughly. I could not separate out the sugar from the water just by like kind of looking at it or pushing some to the side. So that is a homogeneous mixture or a solution. Lime juice, what would that be? A sandwich, what would that be? So try to think about how you can apply this.